Europe has set far-reaching energy and climate goals. Its ambition for the year 2020 is to achieve a 20% increase in energy efficiency, a reduction of greenhouse gas emissions by 20%, and 20% of the EU energy consumption to come from renewable sources.
Surely these EU 2020 goals are laudable.
But can we make it really happen? Well, see for yourself. We take you on a journey across Europe. First, we go to France. Together with partners from Sweden, new methods are developed here for protection and security of smart grids by making them self-healing.
My name is Noureddin Haj Said. I'm full professor at Grenoble Institute of Technology, and I am also the general director of IDEA, which is the common research center between EDF, Schneider Electric, and the University of Grenoble Institute of Technology. Okay, the role of Grenoble research within Integral is particularly dedicated to emergency situations of smart grid operation. And the emergency situation is whenever there is a fault that occurs in the system, such as a short circuit, such as, for example, a tree that hits a line, for example. The idea is with the help of ICT, and ICT is communication and embedded software, and in the case of our embedded software is agent technology, is immediately to detect within some kind of performance of the ICT to detect this outage or this fault, isolate this fault, send correct information, correct orders to the switches in order to isolate, and then reroute the power so that all the customers or the maximum of the customers of the houses will get back power in a very short time. We proved that simulation is not enough because there are some phenomena in the real world that you cannot really, all of them represent them with the simulation. And we have to prove that our functions, for example, the self-healing system, which is based on agent technology, can deal with all those imperfections of the system. And that will not expected because that are of different devices, different manufacturers with different behaviors. Within few years, we end up that it is absolutely mandatory, I'm saying mandatory, to also complement those simulation theoretical development with a really experimental platform. But the experimental platform needs to be also an image of a real system. And that's why we have gathered data from a real system in southern France, and we duplicated that in a smaller scale, of course, a lower scale, to build this smart grid platform representing distributed generation, physical grid, protections, as well as a SCADA system with all those functions that controls the grid with the presence of distributed generation.
The very idea of an agent, a self-healing agent, which is responsible of the clearance of the fault occurring in the power system, the idea is it can assist from the field the operator to re-energize the sane part of the system. Let's now simulate the faults on the power system and let's say how the agent will behave. So once a fault is occurring in the power system, the data will come from the field and then the agent will be able to locate precisely the faults. If the operator is trusting the agent, then he will get the decision from the agent and re-energize the network.
Our next stop is Girona in Spain. Here, researchers and practitioners develop methods into how local networks of renewable energy sources and controllable loads can become autonomous and sustain themselves as if they are a power island, as soon as there are problems on the main grid.
Benvinguts, soc el doctor Sureda i tinc el plaer de rebre-us en el paratge natural del Mar Roig.
So our demo is a critical operational field inside the Integral project. What we have done is to provide a framework to do the management and optimization of the energy demand and production, especially in critical situations. This means when we are acting in island mode without grid connection. So a critical situation is when the grid suffers or a frequency disturbance or a voltage drop, or we have an imbalance on the demand. So imagine a household connected to the grid. Once a critical situation occurs, the system decides to disconnect the house from the grid. And at this point, the load shedding starts if an imbalanced state occurs.
The concept of the islanding of local networks when the need arises is called a microgrid. The idea originally comes from Greece, since it has many islands that must be self-supporting in power because there is no connection to the main grid on the continent. In March of 2010, this proved to be successful when a major power outage occurred in this area.
Aquest passat mes de març, durant 2 setmanes, el poble de Llagostera es va quedar sense electricitat perquè es havien destruït totes les torres d'alta tensió. La gent del poble de Llagostera venia aquí a connectar-se a internet.
Finally, we travel to Holland, to the village of Hoekirk. The Netherlands is home to the world's first live demonstration of smart electricity networks, and here we can monitor how smart grids will impact the family home. This even attracted the attention of national primetime news on television.
Hoe gaan we over 10, 20 jaar met energie om? Het kernwoord is slim.
Een wasmachine die goedkope stroom zoekt.
Dus als het bijvoorbeeld heel hard gaat waaien en er is heel veel windenergie beschikbaar, dan zal juist deze wasmachine aan gaan springen.
Ik ben nu aan mijn portal aan het kijken. Wat je hier ziet is het energieverbruik van de afgelopen maand van mijn woning. En ik ben ook online aan het kijken hoeveel elektriciteit de zonnepanelen hebben opgeleverd.
Een buffervat en een conventionele ketel. En de warmtepomp staat op het dak. Wat er gebeurt is dat de warmtepomp die werkt op elektriciteit. Die haalt warmte uit de lucht, die onttrekt warmte uit de lucht. Daarmee warmt hij het water in een buffervat op. Dus er staat altijd een buffervat met warm water. Bij warmtevraag, dus als wij warm water nodig hebben of warm cv-water, dan wordt dat in eerste instantie uit het buffervat gehaald, het voorraadje zeg maar. Mocht dat te weinig zijn, dan hebben we gewoon de conventionele ketel die zeg maar bijlevert.
As you see, smart energy grids are the near future. They integrate large numbers of renewable energy sources into the power system. They enable the active participation in the network of millions of customer loads. They achieve higher flexibility and efficiency of the overall power system, and they keep it running under all circumstances. In summary, smart energy grids are the key to the sustainable power system of the 21st century.